This is problem 1570. Dot product of two sparse vectors. Um, Given two sparse vectors compute their dot product. You want to implement the class with the initializer and the dot product, which actually computes it. Sparse vector is a vector that mostly has zeros. You should store the sparse vector efficiently and compute the dot product between two sparse vectors. What if only one of them is sparse? Okay, so if we got this, if you take the dot product of each element one at a time, you get this sum of the multiplications. The 1 times the 0, 0 times the 3, 0 times the 0, 2 times the 4, and then so on. So this would be sum of 8. Here, this would be 0 because you always have, there's always going to be at least one 0 in each multiplication. Here, this would be mostly zeros, but the 2 times the 3 here, they're both non-zero, so that's why you have the 6, and that's the only multiplication that doesn't involve any zeros. So as you can see, that's the brute force approach. That would be O of n, where n is the size of each nums array. And since this is the dot product, they have to, both vectors must be the same length. They're always going to have length of at least 1, and it can consist of zeros up to 100. Since this is mostly zeros, as you can see, a lot of this calculation was unnecessary, like especially this one here, because there's so many zeros. Because there's so many zeros, what we could do is, instead of doing each multiplication of each element, which is going to be O of n time complexity, we could just keep track of whichever indices does not have a non-zero element, and then basically iterate through each index of the dictionary for both vectors, and then whenever they share the same index, then you multiply them together. So for example, got this here. So you got a non-zero here. So then you would say like dict of 1. It will be an index 1 and value 1. Then you iterate this. That's a 0, that's a 0, this is a 2 here. So then you have index 3, 4 with value 2. And then similarly for dict 2, we can see that it's going to have 0 with value 1, 4 with value 3, and then 6 with value 4. And then basically you would just iterate through. So here we're doing v1 dot product v2. So then you could just do like for each key in, so like for k in dict1 dot keys. So this would be like 1 and 4, for example. Then you would check if that key also exists in D2. So if k in D2, let's see what we got here, vac. Then you would do like you would have like a total equals 0. Then you would increment that total by the product of dict1 and dict2. And then that's basically it. So I guess we can go ahead and code this now. So we just need to construct dict1 because this is for a single vector. So self.dict equals an empty dictionary. Or we could just say this is a default dict of integer, because the dictionary is only going to contain a single integer for each index. So for I in range length of nums, dict of I equals nums of I. And only do this if nums of I is non-zero. And then, yeah, this is self.dict. So then if you do a dot product of the given vector with another vector, so it would be what I just had up here. So for k in, it would just be for k in dict. If k self.dict and vect.dict, then total plus equals to self.dict times vec.dict. And then that should be it. And it passes all test cases. So that's it for this problem. Thanks so much for watching.